Welcome back. In today's lecture, I am going to talk about one of the algebraic structure that is called group. Okay, and it is possible to show that whenever there exists symmetry, okay, this notion of group comes into picture. Okay, so in engineering problem, whenever we found the symmetry, it is obvious that using notion of group I can able to capture, and due to that reason this notion is very strong. You can also able to understand that you might have heard that Newton's law is only valid in inertial frame of reference. Okay, and it is possible to show that that restriction basically comes into picture due to this symmetry. Means we have, in order to capture symmetry I need group, and whenever group notion comes into picture then automatically we have restriction. Okay, and we are also going to understand using this notion that what kind of restriction basically comes into picture whenever we are trying to apply the Newton's law. Okay, I have already told you that whenever there exists a symmetry in engineering system, then there exists a group, and due to that reason we have to explore this particular group. Okay, in today's lecture you are also able to understand that one thing I have told you, that whenever I am talking about the binary binary system, okay, and you might have seen that our computer system is actually based on this kind of notion that whenever we are adding 0 plus 0, that is 0, 0 plus 1, 1 plus 0 equal to 1, and 0 plus 1 equal to 1, and 0 plus 0 equal to, sorry, 1 plus 1 equal to 0. We are taking this kind of convention, so we have two options here, and I have already told you that we are, if you see the logic, we are considering 0 only. Okay, so using this notion of group it is possible to show that why basically we are taking 1 plus 1 equal to 0. Okay, so let us start the today's lecture. So before starting the today's lecture, some more part from the state space representation is still remaining. Okay, so I am just going to recap that. So what we have seen in previous class, that whenever I have some kind of dynamical system, and whenever we are considering or defining some kind of system, dynamical means here something which is changing with respect to time. Okay, so quickly could you please tell me that if I have some kind of resistor, okay, and if I apply some kind of voltage here, so is it dynamical system or some kind of a static system? Quickly please answer this question. Antara, could you please answer quickly? This is at a static system or dynamical system?
Uh, Static.
Yeah, a static system. It means that if I will change Vt at the same time, means Vt at the same time It is going to change. Okay, so I have some kind of relation like It into R, something like that. Okay, so this is a static system. Okay, whenever we are considering capacitor and inductor, what we found that if I want to see the rise of charge, or whenever flux that is generated, that is always function on some kind of initial condition. Okay, that is actually dynamical system. Okay, now here you can see that whenever we are talking about dynamical system, it means that I am talking about some kind of variable which is carrying the memory. Okay, in the previous class what we have seen, that whenever I have some kind of system, I have some kind of mass, and if I apply some kind of force, okay, Ft, at that time I have two state variable xt0 and vt0, and I have told you that what is interpretation of xt0, all information from minus infinity to t0 that they are carrying by this variable. Similarly, vt0 means all information from minus infinity to that t0 is carrying by this particular variable. So whenever we are talking about a state, means we are talking about some number only, but we are interpreting that number. Okay, because what happens that whenever xt0 we are we are seeing, that is nothing but integral of something, and whenever we are seeing integral, it means that there exists a memory. So state is nothing but some kind of memory carrying variable. Okay, so how basically we are defining dynamical system? Dynamical system is an oriented mathematical relationship, okay, in which two axioms are satisfied. I have already told you that whenever we are developing some kind of theory, first we are blindly we are assuming something, okay, and most of time whatever assumption we are doing, we are not proving, okay. But for engineering system, we can do experiment and we are trying to verify that axiom, okay. So what we are assuming, that whenever I have dynamical system, a real output yt exists for all t greater than equal to t0 to given a real input ut for all t. Okay, it means that if I will define something as a dynamical system, then first axiom should be satisfied. Means if you apply some kind of real input ut, and here you can assume that that is m dimensional input, means u1 u is nothing but u1 u2 to um, something like that, some vector like that you can define. And after that I have some kind of yt, and yt belongs to rp, so I have p number of vector. Okay, so what basically first axiom is telling, that each input is real one and output is also real one. Okay, we are not considering any complex input and complex output. Okay, I will tell you that when complex input is coming, then what kind of interpretation that comes into picture. Okay, that we will deal then when we try to understand the physical interpretation of complex number. After that, output yt do not depend on the input ut tau greater than equal to t. It means that whatever input we are going to apply, that should not depend on the futuristic output. Okay, it means that whenever we are considering this output, that is only consequence of the present input or past input. Okay, that is the meaning of this second statement. So suppose that if you are talking about system, suppose you want to model the share market. So could you please tell me that share market is satisfying these two property or not? Share market, suppose that I want to model the share market, some money is we are investing, and after that we are getting some kind of money. Okay, so what do you think, both axioms 1 and axioms 2 are satisfied or not satisfied? Anyone, could you please guess about that system? Others, or Diksha, could you please comment? Diksha, are you here? Akash Dinkar, Akash, are you here? Akash, you are muted. Could you please unmute yourself and answer the question? Suppose I am considering the some kind of system, share market, like, so that will satisfy the property of dynamical system or not? Ayush, are you here?
Exactly, there's quite noisy here.
Okay. So Ayush, are you able to hear my voice?
Yes, sir, slightly.
Okay. So what do you think? Finance system, okay, whatever share market scenario I have considered, that will satisfy the property of dynamical system?
So for finance system, there if we give an input, real input, there should be a real output. So
So first
the
condition is
axiom one is
satisfied.
satisfied,
Yeah. Second,
and the second is output does not depend on input. Sir, this can I don't think so. This can be true
yeah,
because
it might possible sometime that
yes, sir.
our input, that is also depend on the futuristic situation. Okay,
Yes,
suppose
sir.
that
That is
now
also
take the case of covid. Okay, so if covid is there, so it might possible people start actually taking money from the share market. Okay, so futuristic, if they think that some situation market is going to crash, then what they will do based on the futuristic situation, they are going to take some kind of decision, and due to that reason, if you consider the share market, that will not satisfy the property of dynamical system. Okay, so just one counter example I have given. Now let us come to the definition of state. We have already seen that whenever I have dynamical system, then this notion comes into picture. Okay, the state of an abstract object is collection of number, okay, with together with the input uniquely determine the output. Okay, so I have already told you that whenever we are developing some kind of system, then I have to make sure that whatever output that is going to generate, that should be unique. Okay, so state is nothing but some kind of collection of number. So I have ut, I am going to apply, and I have certain collection of number at the time of xt0, and using that information and collection of number, I can able to define d by t. That is the meaning of the state. Okay, and whatever number that involved in this process, okay, means I have input and output, and whatever extra number that involved in this process, that is called the state. Okay, and I have already told you that most of time whenever we are doing experiment, I know the input, I can measure the input, and I can measure the output. What input I am applying I know, and what output I am applying I know, and due to that reason I have infinite many state space representation. It means that one system can be represented using infinite many way, and due to that reason some guidelines is required that whatever state variable you are going to choose, that is correct or not correct. Again, due to that reason some axioms is there. Okay, and I am going to state that axioms in the next part of this slide. You can see that whenever I have some kind of dynamical system, and I know the input, what kind of input I am going to apply, what kind of output I am going to get, these two are some kind of real number or set of real numbers. After that, whatever initial condition or whatever state variable you are going to select or internal variable you are going to select, that should be satisfy this five property. Okay, then only that is called the state. Okay, so what is first axioms are telling, a real unique output. Okay, and you can see here that whenever I am specifying the output yt, that is function of the time. Okay, this is phi t t0 x t0 ut, that is the solution. Okay, so what happens now, suppose that if you are at this time, this time is t0. Now it might possible that at this time you are here, so trajectory is here. At this t2 I have trajectory is here. Okay, so suppose if you plot the internal variable, so what state is that at any time you are able to see the trajectory. Okay, and if you start from here, you are able to predict the future. Similarly, if you start from here, also you can predict the same future. If you start from here, again you can able to predict the future from t2 greater than equal to t greater than equal to t2. Okay, so a state is telling that if you start from t0, then you are able to track future value t greater than equal to t0. From here, it means that t1 t1 t is greater than equal to t1, then I can tell that what is futuristic output beyond this. Okay, so if we are here and if I know the input, so from here onward I can able to predict the output. That is the meaning. So that kind of solution, if you see phi is the solution, that is depending on t, t0, x0, ut. Okay, so it means that there is no restriction of selecting the initial condition. You can select initial condition anywhere, but you are going to generate the same trajectory. Okay, so trajectory is going to match. That is the meaning. Okay, after that you can see that, so this is the axioms first. So they are telling that output y is function of time, and this whole quantity is initial condition xt0. You can here t0, it means that this is xt0, and ut means all control you have to know for t greater than equal to t0. Okay, second axioms is telling that a unique trajectory, now they are talking about trajectory, exists for all t greater than equal to t0. So if you start from here, then there exists a unique trajectory. Okay, I mean, because uniqueness is very important. Otherwise, whatever machine we are going to develop or we have developed, that is not purchased by any people. Okay, so same kind of things they are telling, that each time t0, each initial condition x0 and u tau, you are going to get unique trajectory. Okay, and after that I have told you that unique trajectory start from each state. So now there is no need to worry. If your system is same, then you can start anywhere. You are going to get the unique trajectory, and trajectory will also satisfy the transition property. Transition property means, I have told you that you can see here that I have started with t0 and xt0 is the initial condition. So whatever trajectory that is generated, that is equal to, even if you start at t1 and at that time state is xt1. Okay, so same trajectory is going to maintain. So that is called transition property, and trajectory does not depending on the input or futuristic input that is telling, that is fifth axiom. Okay, so whenever you are going to select the state variable, okay, and suppose that if you are allowing computer to select a state variable, then this all conditions or axioms should be satisfied. Okay, most of time whenever we are writing rule, it means that we are writing for our guidelines. Also we try to in future what we expect, that I will write this kind of program to some computer and computer automatically select the state of any dynamical system. Okay, and due to that reason we are making some kind of assumption, and you can see that that assumption is globally accepted by everyone, those who are going to explore the system theory, and due to that reason that is called axioms. Okay, so I have two axioms to define dynamical system, I have five axioms to define the state of dynamical system. Anyone has confusion on this point? And due to that reason means, you can see that we are very much consistent like mathematics. Okay, we are first defining something, and after that based on that we are going to develop all kind of theory. Now let us come to the so just I will give one counter example. You can see that here what I have done, I am trying to construct some kind of dynamical system. Okay, I do not know the internal variable, but I just know the relationship between input and output. And what we found, that here we have already seen that ut should be real number and yt should be also some kind of real number. Okay, so suppose that if that will related like yt equal to jut. Okay, so could you please comment, this is dynamical system or not? Yt equal to jut, that is dynamical system or not?
No, sir.
No, because if you select ut as a real number, you can see that yt become complex or vice versa, and due to that reason this will not satisfy the property of dynamical system. Okay, now let us come to this dynamical system, dyt by dt equal to ut. Okay, so here ut and yt is related by some kind of differential equation, and obviously I am assuming for the simplicity ut belongs to some real number, and ut also belongs to some kind of real number. Okay, now I have written this whole quantity like this, dxt by dt equal to jut, and here I have selected yt equal to minus jxt. Okay, so what do you think, this representation is okay or not okay? Antara, could you please comment?
Uh, why have we written dxt by dt?
dxt by dt jut I have written. Okay, so what happens, that I know that input and output is related like this. After that what I have done, I have defined yt equal to minus jxt, and after that if I will do dy by dt here, you can see that j, and this is dx by dt. Okay, and dx by dt I know that is actually j into ut, and j is j square is minus 1, and due to that reason I will get ut. Okay, so in this way it means that I can able to write mathematically, I can able to write this like this. Okay, now we are going to check that is this representation is okay or not okay. Okay, it means that what happens, I know that these two quantity should be real, but never I have commented that this quantity is real. Okay, so internal variable, and most of time internal variable I am selecting based on our convenient. Okay, that might be complex number. Okay, but that should be those kind of complex numbers such that if I apply input ut, then whatever output that is going to generate, that should be real number. Otherwise I cannot measure, because whatever sensor technology we have developed, that is only able to understand the real number. Okay, so here you can see that if x is some kind of complex number, pure complex number, then obviously yt is some kind of real number, and due to that reason this representation is okay. Anyone has confusion? And if you solve the equation, then all five properties satisfied by this equation. Okay, so please do this exercise by yourself. Anyone has anyone has confusion? It means that what I am going to say here, that if you have some kind of system, then you can use complex number to explore that system. Okay, that is not a problem, but whatever input and output, that should be real number. And due to that reason you might have seen that during analysis purpose several times we are using the complex numbers. Okay, but for realistic application always we are limit ourselves, because application means we don't know what kind of internal things that is going to occur inside this system, but we know that what kind of excitation we are applying and what kind of response we are getting. So excitation and response should be real or set of real number. Anyone has confusion? Okay, now let us come to the algebraic structure, because I have told you that whenever I am trying to capture some kind of dynamical system, so in order to get the mathematical modeling of something, I need some kind of law from the classical mechanics, quantum mechanics, or some other places like chemical, some kind of chemistry, using some kind of biochemistry. So some rules should be there. Okay, and whenever some rule comes into picture, we trying to formulate those kind of rule which will true in larger space. Okay, and how to confirm that that rule is true in larger space, I have to tell that that rule is invariance with respect to certain operation. Okay, and it is possible to show that if we are going to see that in which particular set that rule is true, then notion of group comes into picture. Okay, so I have already told you that whenever I have unordered world, I am going to use the notion of set. Okay, so whenever I am representing some this system, I have told you that is autonomous system. And autonomous system, suppose that this autonomous system in some space, I don't know that space, this is D. If x belongs to D, then we are writing x that is subset that belongs to D, and D is subset of Rn. Okay, and dimensional space we have. So you can see that whenever I have to collect something, we are using the the notion of the mathematics that is called set subset, like that. Okay, after that what we have to do, we have to also show the mapping. So here mapping is x, so and I know that x belongs to D, and if some quantity belongs to D, it doesn't mean that their derivative also belongs to the same space. And due to that reason I can tell that f, although x belongs to D, but their rate may be very large, and due to that reason that map to Rn. Anyone has confusion on this point? Why I have written f map to D to Rn? We are trying to tell that f is some function that is mapping, and x state is lying in this space D, and that map to Rn, because x dot, because here x dot equal to fx, so quantity is x, then rate of change, okay, that is going to represented by fx. So x is limited in this region, but we know that some quantity x is limited in some quantity, but their rate may be higher, and due to that reason we are writing like this. Okay, and here basically we are using the notion of function. Okay, similarly if I change here x dot equal to ftx, then at this time my function has one extra variable. So this extra variable is nothing but time is real number, positive real number, Cartesian product of that is Rn, and that map to here x is d, sorry. So x should be d in a space of d, and that map to be Rn. So I need the Cartesian product to represent this non-autonomous system. Okay, this system is called autonomous system and this is called non-autonomous system. Okay, so everywhere we are using this set. Now once we formulated the mathematical model, at that time I have to perform some kind of operation to control that particular system. Okay, suppose now you want to implement this kind of system using some kind of computer, and you know that computer system is just working on binary number, that is 0 or 1. So logic is 0 or 1. Okay, so you have to operate. Okay, so what kind of operation is possible for 0 and 1? Either I want to add, I want to multiply, I want to divide, or I want to subtract. Okay, so 4 operation we are doing. Okay, now these all operation are called the binary operation. It is possible to show that just by addition and multiplication I can able to perform all operation. Okay, and due to that reason in higher level you are able to see that we are just defining two operation, that is addition kind of operation or multiplication, but that is not exactly classical addition. Okay, because suppose if I want to add two chemical, okay, so at that time I am getting third chemical that is not following the same property like 1 plus 1 equal to 2. Okay, and due to that reason I have to define what is meaning of operation, but I have to make sure, I have already told you that whenever we are talking about binary operation, then a is some set operated on a. I have to make sure that again whatever quantity that comes into picture, that is a. Okay, this is called operation. Okay, operation may be anything, so that is called binary operation. And after performing, so a is some kind of set, we are performing one operation, binary operation. It might possible I have given some name like addition, multiplication, that doesn't matter, and after that we are getting resultant, that is called magma. Okay, and you can see here that if magma will satisfy certain kind of rule, certain kind of axioms, then that is called group. Okay, so in today's lecture I am going to explore this part only. I forget the all top thing from here onward. Okay, so you can see here that I have defined the group. So a group is a set X together with the operation. Okay, so whenever I am going to define the group, at that time I have to select some set, and after that I have to select some kind of operation. Okay, you can give name based on the property of the operation. Okay, so this is set and this is nothing but some kind of binary operation. So please be careful here. Binary operation doesn't mean that I am just performing 0 and 1. Binary means I have set x, I will operate on x, and if I will get x, then that is called binary operation. Okay, so that is generalization of binary 0 and 1. Okay, now what we are telling, that this binary operation should satisfy first property, that if x1, that is element of x, if you operate on x2, then whatever quantity that comes into picture, that should be belongs to the same group. Okay, or same set X. Now second property, that is called associativity. What you can do, you can operate, you can select three quantity from the set X, x1, x2 and x3, and you can first operate on two quantity, and after that whatever resultant you can operate on third quantity. And if you change this order, then order remains the same, and this rule is called associativity. Okay, and after that you can see that we are talking about there exists an element. Okay, we are telling there exists. Okay, such that if now you operate this element to any element of this set, then you can see that always we are going to get the same element. Okay, so that is called identity. Okay, and now you can see here that for every x that is belongs to this set x, there exists some element y belongs to x such that this relation will satisfy, and this is called basically the inverse. Okay, so I have first defined the ground is I have set with binary operation, and after that I have defined the rule of the play. I am going to play some kind of game, so these are the game. Okay, and if these rules are satisfied, then we are telling that we are okay. Okay, we are not violating any game. So same kind of things you can see, that associativity, identity and inverse, and after that binary operation always preserve that a apply on a, we are getting on a. Due to that reason, four different things should be satisfied in order to define some notion like group. Okay, and you try to understand like this also. Suppose you are talking about symmetry, so if you apply symmetry on symmetry, it is possible to show you are again get the symmetry. Okay, if you are, or suppose that we are talking about rotational symmetry. Okay, so if you are rotate some object x by some rule, you are whatever things you are getting that, and suppose that we are in some particular way of rotation, then we are going to remains on that. Okay, so symmetry apply on symmetry remains symmetry, order doesn't matter. And if, what is meaning of identity there, if you do not perform any operation on symmetry, that is remains the symmetry, and it is possible to inverse the symmetry, that is the meaning. Okay, and due to that reason, whatever notion of symmetry, that is exactly whatever we are writing here in mathematical form. And due to that reason, I am claiming that whenever I have symmetry, there exists some kind of group. Okay, it might possible I have some kind of abstraction also where we are not able to interpret in terms of symmetry, but for our purpose, symmetry we are going to identify in order to define some more rule. Okay, so remark is that one can also explain the above definition as a group is a set together with associative operation such that there is an identity and every element has inverse. Okay, so always there exists an identity and always I have inverse, and any pair of element can combine without going outside the set. Okay, so it means that x operated on x, that should remains on the x, and these kind of definition you have already learned during your btech first year, I hope. Okay, or some course of algebra you have learned this kind of definition. Okay, so what basically we are doing, we are trying to understand the definition and why people has given the definition. Okay, so main motive of this definition for our use is to represent the symmetry. Okay, one more thing what we found here, whenever I am defining this element that is called group. Okay, so group element is satisfying the closeness property. Closeness property means you can take two element and you can operate, then we are going to remains on the same space, that is called closeness property. Second property is associativity, we have seen. After that, inverse and identity. Okay, we are not talking about commutativity. What is meaning of commutativity? Suppose that x1 is some element and I will operate on x2, and whatever things I am getting, I am telling that that is exactly equal to this, where for all x1 and x2 that belongs to x. Okay, so if I have set x, you can take any two element of this set, and if you perform this kind of operation and if that is true, then this rule is called commutativity. Okay, and if group apart from all four property, if they will satisfy this additional property, then that group is called abelian group. Okay, anyone has confusion on this definition? So now could you please define the non-abelian group? Anyone, could you please define the non-abelian group? How to define non-abelian group? Anyone? Abhishek? Could you please define non-abelian group? Antara, could you please define?
Where the commutative property is satisfied, because we
Commutative, when commutativity property satisfied, then I have defined that group as a abelian group. Apart from all four group property, fifth property is called the commutativity. So apart from four property, if fifth property is also satisfied, then we are telling that group as a abelian group. Okay, now we are trying to define non-abelian group. Okay, so obviously if somewhere this property is violated, at least at one place, if this property is violated, then we are telling that group as a non-abelian group. Okay, suppose commutativity will satisfy for large number of place, but if that is violated at one place, then we are telling that that is a non-abelian group. Okay, so whenever we are defining group, okay, at that time it might possible that commutativity property will satisfy, sometime it might possible commutativity property will not satisfy. Okay, anyone has confusion? Now example, so during your BTech first year course or some place, you might have seen the example, or in some course in computer science you might have seen about group, because all all programming language is basically based on this concept: group, ring, field, these kind of concept people are using. So now here you can see that one point, that we are considering the real number. Okay, so one obvious example I am telling. So real number, suppose, so real number with proper addition operation. If I will take proper addition operation, it means that 1 plus 1 equal to 2, 2 plus 3 equal to 5, something like that. So could you please guess that with respect to addition, that form a group or not? So what is identity element? If I have real number with classical addition, real number with classical addition, could you please guess that what is identity operation? Asutosh Singh, Asutosh, are you here? Why audience are so much passive?
So
real
zero will be the identity.
Yeah, 0 is the identity or 1 is the identity. What do you think? When 1 is the identity and when 0 is the identity?
Well, when
Suppose I have
additive
real number.
property, when additive property is concerned, then zero is inverse. Otherwise, when multiplication, this is one.
Yeah. So whenever we are considering multiplication, then 1 is identity, because definition of identity, if you see, then what basically we are telling, if I will take any element and if I operate, then I will get the same element. Okay, and due to that reason we have to, whenever we are talking about the additivity or any property or inverse, we have to see the operation very carefully. Okay, so if we are talking about addition, then what happens? With respect to addition I have different identity, with respect to multiplication I have different identity. Okay, and I hope that that is very simple to know, okay, from definition. And could you please able to verify that there always exists some kind of inverse? So suppose if I am talking about the real number with classical addition, then what is inverse for that? Anyone, could you please tell quickly? You can tell. Ayush, could you please comment, or Ankur Gupta?
Yes, sir. Pardon?
So suppose I have some kind of real line or real numbers, and I have fixed the operation as addition. Okay, so what is inverse? Inverse always exist or not? First, could you please tell me?
The
In case of real number multiplication.
negative of that number.
Yeah, so negative of that number. Okay, so I hope that this kind of things you are already means you are already able to recognize, and due to that reason I am not actually discussing this kind of obvious examples. Okay, now let us come to some complicated example. Okay, and first I am going to show that if group has only two elements, that must be abelian. Okay, so suppose that I have some group and I have just two elements. Okay, so I have taken two elements A and B. Okay, and I am assuming that using these two elements, okay, I don't know the operation for time being, and now I am going to show that the if two element, then commutativity is always satisfied. Why? Because we know from the definition of group that whenever I have group, then always there exists an identity element. Okay, so one element I have to fix as an identity. Okay, so either you can fix A as an identity or B as a identity, that doesn't matter. Okay, so suppose if I fix A as a identity element, I have denoted that element as a E. And what is property of identity element? That if you apply A on E or E on A, then we will get the same element, that is A. Okay, even if you can apply B on E or E on B, then you will get B. Okay, that is the meaning of the E. Okay, identity element. Anyone has confusion? From the definition, I'm not making any extra assumption. I'm just going back to the definition. You can see here in definition what they are telling, that there exists an identity element such that I, if you operate in any element, okay, first identity operated on X or X identity operated on that element I, we are going to get X. Due to that reason, this property, from if I have just two elements, then I can tell that I have to fix one element as a entity, because I am telling that inside group I have just two elements. Okay, now I have to make sure also that fourth property, that is inverse, that should be satisfied. Okay, and what is meaning of inverse? That I have B and I am telling that second B is the inverse of something, so it might possible that B is the inverse of itself. Okay, so what I have, because I have two elements, so I don't have option, and due to that reason I have selected B inverse B inverse as a B. Okay, so one element I have selected as a entity, another element I have selected as a B. Okay, please think that why A is not both identity or inverse. Okay, if you see the rule, then you are able to understand that why same element is not entity as well as the inverse. Okay, so just you can check for that, that is not difficult to check. Okay, now you can see here that what I am telling, that I am going to operate A on B, and where A element I have selected as an entity, so it might possible that EB or BE I will write, both are exactly same, and after that I am going to replace A by E by A, because I have defined A equal to E, and due to that reason AB equal to BA. So whenever I have two elements and we know that that is going to form the group, we know that, then that should be abelian. Okay, if that will not form group, then we are not going to comment about the abelian. So we are assuming that I have some kind of group kind of structure. It means that all four properties satisfy. Then now I am claiming that commutativity will also comes into picture, and one can easily able to show this kind of point. Okay, now let us come to the second example. Second example is little more interesting for us, because we are using this kind of example in order to develop all operation inside the computer. Okay, what we are telling, now suppose inside some kind of group I have just two element. Okay, so I have two element, then what kind of further possibility that comes into picture, we are going to look through. Okay, so what happens, that I have two element E and A. E you can assume as a entity. Okay, so I have E and A, and this table we are telling that composition table. So composition table means I have performed some kind of operation, and I have fixed one element as an identity. Okay, so now could you please tell me that if E is identity, then what kind of entry will come here? E operated on E, then that is A or E.
E.
Okay, because E I have fixed as identity. Now E operated on A, you can see that is A. Why? Because E is identity. Again A operated on E, then I have A. Now contradiction is here, that if A operated on A, then what kind of possibility I have, what kind of things that comes into picture. Okay, so I have here two possibility. What kind of possibility I have here? Either I have A or E. Okay, now what you have to do, you have to select one, and by contradiction you have to show that is not possible. Okay, so suppose that if you select first, you can select A. So what I am telling, A operated on A, that will gives us A. Okay, then what kind of contradiction comes into picture? Could you please guess? Or second time what I am telling, A operated on A, that is E. What kind of contradiction comes into picture if I will believe on this rule?
It means that A is an identity. That is what it's representing.
Okay,
But you've
so
chosen E as an
so you
identity.
can see all four property. We have seen that E I have selected an entity. So what I have to do, I have to select the inverse, and each element should have some kind of inverse. Okay, it means that, and here if A operated on A, it means that if A is inverse of A, then that will produce the identity. Okay, because if you see the definition carefully, then identity and inverse are not separated. Okay, once I fix the identity, then now fourth property that should be involved. Here you can see that if X operated on Y, then I have to prove that there exists identity. It means that each element there exists some kind of Y such that I can get the identity. Okay, and due to that reason, due to this property, you can see here that if I do A operated on A equal to A, then that property should be violated, and due to that reason, and but E operated on E, and it means that each A element is the inverse of itself. E element means each element in this particular group has also works as their own inverse. Anyone has confusion on this? So A is the inverse of itself, E is the inverse of itself. Anyone has confusion? Now what you can do, in place of E, you can substitute some value, and what value I am telling, that you can substitute. Now one time you can substitute E as a 0, one time you can substitute E as a 1. Okay, and try to see the table. Okay, so what kind of table basically that comes into picture? Now I have here E, so 0 1, and here 0 1. So I am telling that here I have 0, here A I have selected as a 1 1, and here basically I have fixed that this should be E. So again that is 0. Okay, now if I replace this operation by plus, now could you please able to interpret? 0 operated on 0, that will gives us 0. So 0 plus 0 equal to 0. 1 operated on 0, that will gives us 1. So 1 operated on 0, that is 1. Second thing, you can see here that 0 operated on 1, that will 0 operated on 1, that will give us 1, and after that 1 operated on 1, that will gives us the 0. Okay, and same logic basically we are following. Okay, now if you have some knowledge of gate, could you please tell me that what kind of gate, what kind of physical circuit is implement this kind of logic?
That XOR.
XOR. Okay, and due to that reason, if you see the hardware, computer hardware, then this gate is used. Okay, now try to understand, this is about the addition operation. Try to understand the multiplication operation. Okay, so actually whenever we are multiplying, so we have to follow the same rule. Okay, at this moment, now you can reverse the order. E you can select as a 1 and a you can select as a 0. Okay, and obviously whenever we are defining multiplication, then we are avoiding 0. Okay, so this side you have to avoid. Okay, so what basically you have to do now, 1 operated on 1, 1 multiplied by 1, that will give us 1, 1 multiplied by 0, that will give us 0, and here again 1 multiplied by 0, and here what happens, that a I have fixed 1, e I have fixed 1, a I have fixed 0, so that is 0. Okay, and this place either you can write, that doesn't matter, that 0 operated on 0, that is 0. Okay, so I have set that. So what kind of gate is required to implement multiplication operation? Anyone, have you understood?
And gate, sir.
So here I have AND gate. Okay, so whenever you are seeing the hardware circuit of any computer, so if I have just two gate, then I can able to define any operation. Okay, so due to that reason, hardware of any computer circuit is actually composed of these two. Anyone has confusion? So due to that reason, I am telling you to read the group. Now you can see that people are talking about the chemical computer. Now in chemical computer also we have to do some kind of operation like addition, multiplication. Again, you have to confirm that group kind of notion comes into picture. If that is not there, then what happens, that it is very difficult to perform all operation. Okay, because if something is symmetric, then we are able to reuse it at several places. Okay, and due to that reason people are searching that kind of things, and group is also telling the same. So group is just some kind of mathematical way to capture the symmetry. Okay, so in this way you can also able to understand the cryptography. Okay, if I have time, then I will explain that how basically cryptography mechanism will work. Okay, and another example that is obvious, that is you can consider the complex number, and after that operation you can consider as a multiplication. Okay, and it is possible to show that all four operation will satisfy. Okay, so this example is obvious, so I have selected one obvious example also, and you know the identity what is inverse. Okay, so please check by yourself. Okay, so now it is time to conclude the today's lecture. That in today's lecture I have given the introduction to the group, why group is relevant for us, and after that we have also seen that whenever we are seeing the computer hardware circuit, then what kind of possible gate one can use such that I can able to perform at least two operation. Okay, and we all are knowing that all operation basically we are mapping based on 0 and 1. Okay, second class we are going to see that, suppose that several places whenever we are dealing with robotics, electromechanical system, several places we are basically using the idea of Newton's law. Even if you might have seen that in heat flow, Newton's law of cooling, several places we are using. Okay, by analogy also we can see that electrical circuit is exactly means behaving like the mechanical element like mass spring damper or something like that. So now under which situation that law is true? Okay, and we know that that law is true if we are going to consider some kind of inertial frame of reference. Why inertial frame of reference comes into picture and how that is related to the group. Okay, so that kind of things we have to understand. Okay, and if we are able to understand, then we are also able to understand the quantum physics. Okay, so due to that reason group is very important element. Okay, so with this remark I am going to end the today's lecture. If you have any confusion, then please let me know, or you can ask in next class, that is not a problem. Okay, if you don't have any confusion, then thank you very much.